the reality is you don't need that level of privilege to actually steal something, and this is something you really need to think about. So it's easy to steal. That's what I'm talking about, the middle bullet point here. It's not rocket science. What you really need is just access to various users' accounts within the organization to be able to do something that involves stealing physical things, such as money. So real theft doesn't require complex techniques often. So you know what happens in real life, exploits can be downloaded for free. Possibly somebody could steal with those exploits, but in reality people steal data or do things not because of exploits downloaded from the internet. They steal them because of the permissions are so weak in databases, because data is just lying around everywhere. We as customers of Oracle who build Oracle databases, we tend to not think about security when we deploy the application. We leave the data lying around. We often duplicate it in massive quantities. So that's really sort of summarization of we need security, and we're talking about the key issue for me, which is the security of the data. We'll now go and talk about the traditional approach. Most people for the last few years, when they think about database security, if they've done something about database security, they basically do some hardening based on a checklist. In the UK, certainly, and across Europe, most databases don't have much work done on them in terms of data security. There are a number of checklists out there. There's the SANS step-by-step, the SANS score, the CIS benchmark, the DoD STIG. Most of them have got similar levels of checks and fixes and tips and so on in them. You know, people follow them generally over this side of the pond. We don't follow them very far on the US side of the pond. I tend to see databases that have been following these lists to a much more depth, and that's generally because you've got more regulation over there, so things like SOX and HIPAA and so on. But is hardening a database by a checklist, is it a good idea? Obviously you can't respond to me, so I'll answer it myself. In my view, no, and the reason is that not many checklists exist. Most of them are very similar. They come from a similar sort of source. They've got similar sorts of content, but that isn't the main issue. Most of them are tip-based. We could relate this to the tuning world of the Oracle database. You know, people who've done any tuning in Oracle database have heard of this phrase compulsive tuning disorder. So you go to a website, you find a tip that says set this parameter to this value. You know, application queries, the database runs a bit faster. You pick another tip, you set another parameter to a different value, the database runs a bit slower. Is it a combination of both tips that's causing it now to run slower? So you remove the second tip, you go and look for a third tip, and so on. These checklists are really of a similar ilk. They're really just tip-based. They're about basic hardening. These lists don't focus on securing the data. If we want to secure a database, we shouldn't think about securing the database software. We should think about securing the data. We have to know where the data is. We have to know who can access it. Then we can think about securing it. These lists don't do that. The Center for Internet Security benchmark, for instance, the version 3, has something like 158, 154 pages, depending on how you printed it out, whether you're using the page numbers from the PDF or the actual page numbers. It's really irrelevant. And you know, each page has got a number of checks in it. Maybe there's 300 to 400 checks in this document. If you follow that complete document from beginning to end and you apply all the advice to your to one complete database, is your credit card data or your aid status or your banking details any more secure? No, it's not, because these documents don't mention anything. This is a big problem. The second side of it is that solutions are a problem as well. We could have a time-based solution, or we could have a clever-based solution. I'll explain what this means in a second. Often most organizations don't have a dedicated database security person. Often there's a security team, maybe an internal security team in a big enough organization. They're going around and they're really focusing on desktop security, firewalls, and so on. They don't generally have somebody from the DBA team involved. You know, if you want to secure your databases, you have to think about money. You have to think about finance. You have to put forward some man days, man years to actually think about securing your database. This is a problem. Securing a database costs a lot of money if you take the approach of following a checklist. Imagine a checklist with 400 checks in it. Imagine you've got 100 databases. You know, that's what, 40,000 things you have to fix. You're talking about man years of work to diligently go through all of those databases and do all of that fixing. The problem is, as I've just explained, it doesn't say anything about your data. So your data is probably still just as insecure as it was at the beginning. You've brought up the level of basic hardening, but you haven't secured the actual data. The second part of this is that often solutions are not as easy as you think they are, because solutions often need correlating evidence and facts, and things work in tandem. They work differently based on different versions of Oracle. They work differently based on different operating systems. They work differently based on the fact you've got different applications and so on. So one solution for one particular problem in one database might not be the solution in another one. So you have that complexity as well. So generally in the database world, we have to accept that we can't fix 400 things in every database. We need clever solutions. So the time really transfers to the clever part, and we really say that if we have to start off with how much time have we got to do this. We have one person for a year or one person full time. Maybe in a year we want to achieve a certain level of security. Then that person needs to start coming up with clever solutions. So we need to put wrappers around the data. We need to have an onion-based approach. We need to put security around the data at its source. We need to put security around access to the database in terms of people being able to connect. We need to put security in terms of understanding who is connecting and what they're doing, so auditing and so on. So there's lots of things we need to think about, unfortunately, in database security. Is that there are some problems with them. The version 3 of the CIS benchmark, I just picked one thing as an example here. The version 3 of the checklist has been enhanced. They've added solutions to every check. Hopefully you can see my screen here. Check 302 states that all files in Oracle Home Bin must have privileges of 755 or less, or stronger. But that solution then states chmod 755 Oracle Home Bin star. Is that a good idea? I think not. If you actually look at the permissions in that directory, you will see that some files in that directory are actually got stronger permissions already. So applying a solution from a document often may actually weaken the security. So you have to think about what you're doing. And the second point in this slide really emphasizes this, that a solution often isn't as simple as just following an action in a document. So take the example of a weak password. Imagine that you discover that the schema owner for your application might be called Orablog. It's called Orablog in my database. Maybe the password is Orablog. The solution seems to be to set it to a strong password, maybe 15 characters long, with random characters and digits and special characters. Great. But that's not the complete solution. The complete solution should include password management as well. We should make sure that the weak password can't be reset. We need to find out where it's hard-coded. We need to also think about password management for not just the password complexity, but making sure that account's locked if somebody tries to break in. That leads us into audit. We have to think about finding out who's trying to connect to this account and so on. So solutions for Oracle databases are often complex because we need to think about this layered approach. So we need to have multiple things that we're doing. And really the first point was highlighting, don't just follow the list.